So now we are going to see the theory of gas carriers. So gas is transported as liquid because in liquid it can be compressed around 650 times than its gaseous states, and the relative density of gases vary from zero 0.42 methane to 0.97 vinyl chloride monomer. So as per the cargo capacity, the dead weight of the with the density, dead weight will change. So the main cargo in gas ships are methane, which is LNG, and then LPG. You have butane, propane, or a mixture also sometimes we carry, and ammonia. And these are very significant cargo, and others are butadiene, butylene, ethylene, propylene, vinyl chloride, that VC. Then apart from ethylene and methane, all the others are existing as liquid at normal temperature. So ethylene and methane are not liquid at ambient temperature, and therefore they have to they have to be transported in pressurized containment system or refrigerated. We will see. Sorry. So we have different types of gas carriers, like fully pressurized, semi-pressurized, and fully refrigerated. So there are critical temperatures for many gases, which you can see in the tables, and their carrier temperature. So critical temperature above which the gas cannot be transferred to a liquid. So LNG requires fully refrigerated or semi-refrigerated. So butane is boiling point is minus 0.5. So it can be carried in fully pressurized ship. Then you have butene and vinyl chloride and ammonia. And these are the boiling points. Then you have propane minus 43 or propylene minus 48. So if they are carried in refrigerated, they have to be carried below this temperature. They are carried at pressurized. They have to be carried in this much pressure. So you'll see very high pressure. Then ethylene and LNG cannot be pressurized, so they have to be carried in fully refrigerated ships only. Then some basic definitions. What is a gas? We already saw. Any vapor exceeding 2.8 bar pressure at 37 is gas. Boiling point is at temperature at which the liquid changes to vapor. Then the cargo area, part of the cargo system is the cargo area, which has all the pumps and everything, compressor room, all the deck area. So these are some definitions. Gas danger zone is all deck. Accommodation is gas safe space. Hold space is, we already saw, primary barrier, secondary barrier. Then we have to see what are the main hazards of gas carriers. So flammability, toxicity, asphyxia we have seen. Frostbite due to very low temperature, and chemical burns are excess hazards other than other ships. So then we have reaction hazard. So reaction, it can react with water and form hydrates, which we saw. And to avoid hydrate formation, we are using methanol. So hydrate is when the cargo is reacting with water and incorrect dew point, and it can form crystals. Then we are adding antifreeze like methanol or something, or we can add some inhibitors but that will be as per the shipper and you'll get the certificates. Then there are some cargoes which do self reaction like polymerization, and for that we need to add inhibitor. So it will be under the supervision of charter and shipper, and there will be a certificate. It will indicate the quantity and name of inhibitor on the date and how long it is will be effective. Should we need to add more inhibitor in the voyage, how much, and the temperature limitations, all details will be there. So inhibitor, like you have studied, there is in chemistry reactions, catalyst increases the rate of reaction, inhibitor slows down the rate of reaction. So if the cargo is self-reacting, it can polymerize, it forms like a cake, then cargo texture will change, it will be contaminated. So avoid that, we add an inhibitor, it's like a powder, and with that the cargo will not polymerize or contaminate. Then some cargoes react with air like oxygen or something to form some compounds. And some cargoes react with other cargoes, of course. Many cargoes react with other cargoes. If there is a leak or they mix in the pipelines or in the tanks, then it can cause problems. So we have to segregate them. But generally, this is not a problem in gas carrier because most of the ships are carrying same cargo on full ship, not like chemical tanker. But if it is there, then it can be. Then react. Sometimes we are carrying like propane, butane in other tanks, but they are not uh, dangerous to each other. Then reaction with other materials. So it can react with the tank coatings, as we saw for chemical tankers, or any gaskets. It can damage rubbers, heating coils, nuts, bolts, or pipelines. And if it goes into the hold space, it can damage the insulation. Then if the reaction is between cargo and vapors, the inert gas with CO2 content can cause carbonate formation with ammonia, and can cause if it goes into the reliquefaction plant, it can damage the compressor oil also. Then, of course, many cargoes are corrosive, not the LPG and LNG, but other cargoes which we saw are corrosive. Then low temperature effects, of course, carried at very low temperature. So brittle fracture is there, cracks and all. Then, of course, the cargo can spill, and then again spillage will be there, will be expansion into gas and very low temperature sudden. So again, brittle fracture and all can be there. So we can use a water hose if there is a spill to immediately make the liquid gaseous. Otherwise, if the liquid is there, it will damage all the steel. And if the spillage is in the tray, cover the tray and protect from any contact, and you can allow it to evaporate. There is a spill tray in the manifold. Then cooling down process we have seen. Then there is something called ice formation. So if there is a water in the system, of course, you are cooling to less than 0 degrees centigrade, so it can form ice, and then it can damage the pumps. So we are using antifreeze for them. Okay. Then rollover is the mixing process, like we saw boil off in the gas. So mixing of inside the tank, the liquid and vapors are getting mixed, or because that there is a different density, and that is called rolling over. That is mixing of vapor and liquid because of the density difference. So top layer there is boil off, so it will become lighter, and sometimes if it becomes dense instead, so it will go down, and that will be rolling over of the cargo. Cargo will roll from top to bottom. Then there are types of gas carriers: semi-pressurized, fully pressurized, fully refrigerated, ethylene ships, and LNG ships. So fully pressurized, very simple with this cylindrical tanks, type C of 18 bars around or up to 20 bars also. Thermal insulation or reliquefaction plant is not allowed, but they can go only to pressurized terminals. That's why we have semi-pressurized ships which can go to both uh, really refrigerated terminals also and pressurized terminal also, because many ships had these problems. So semi-pressurized are ranging for cargoes up to 5.5 to 7 bars or up to minus 48 degrees centigrade pressure. Tanks are from 3 to 20,000 meter cube, type C tanks, semi-pressurized. Then ethylene ships are for minus 104 degrees centigrade, 1000 to 12,000 meter cube tanks, type C tanks. Then fully refrigerated ships for some LPG, ammonia, and LNG. All force independent membrane tanks, type A. Then LNG ships are carrying cargo up to minus 162, and very big ships, because a lot of LNG everywhere, the fuel is required, and size is very big, 25,000 to 135,000 meter cube, biggest gas carriers. So by size also you can identify, and very big life, 20 to 25 years. Types of tanks are gas transport, taking gas, Moss, and spherical. Then tanks we have seen separately. Then we have pumps, same like chemical tankers. We have like frame type pumps or something, and there are high level and automatic shutdown alarm systems. Then reliquefaction plant we have seen. This is on ship. The reliquefaction plant looks like this. Then different processes of inerting, gassing up. Then these are the uh, precautions you are asked sometimes about loading, discharging. So before loading, we have first thing always we have to do the shipshore safety checklist, which is mentioned in ISGOS. ISGOS shipshore safety checklist has different parts. First is for general, and then for bulk carriers and bulk oil tanker, chemical tanker, and gas tanker. So we have to fill the gas tanker part and the general part. So the checklist, which will include cargo tank, relief valve, and high alarm pressures, remote operated valves condition, they are operating, all the valves are operating properly, alarms are proper, reliquefaction plant is okay, gas detection system, maximum loading rate is agreed. Then all the terminal information regarding if there is any inhibitor or cargo or antifreeze, ballasting, deballasting, all storage plan, loading sequence, discharging sequence, stability, stresses, all every stage is calculated. Sloshing effect of the tank during loading, and if it is loading fast and tank is not damaged, and during the voyage also. Then will the LNG be used as a fuel or not? So if the LNG is used as a fuel, then the boil of LNG, uh, there are two factors. This is the purest and least pollutant, and very cost savely also. We don't need really question plant, we can directly put the gas, but the cost and this thing has to be ascertained and agreed, and your engine must be compatible for using this. So they have a special design for using LPG as fuel in the turbines, gas turbines. Then we will see IGC code. So It's a main code of like a Bible of gas carriers. So we will see. So this is the IGC International Gas Carrier Code, which gives a list of all the cargoes, and chapter 19 it gives substances of the list of cargoes. So International Code for Construction Equipment of Ships Carrying Liquefied Gases in Bulk, and it applies to all ships carrying gas cargo above 5 and um, carrying gas cargoes, and the list is in chapter 19. So basically, all the hazards of the tanks, which pipeline, what type of tanks, what type of venting, what temperature, what precautions, what hazards are there, everything is given in the IGC code, technical requirements. So these are the contents of IGC code. Uh, General classification, definition, surveys, and certification. So we'll have certificate of fitness, same like chemical ships, but here it is for gas carrier as per the gas code. Then you have survival capability of the ship. You always we are asked question that we will see. Ship, tank, gas carrier types as per survival capability. Then that is 1G, 2G, and 3G. Then location of cargo tank. Then ship arrangements, cargo containments, process, pressure, vessels and liquid, vapor and pressure piping system. What are the materials of construction, cargo pressure, temperature, venting system, environment, electrical installation, fire protection, ventilation, gauging, PP, limits of cargo tanks, filling limits, cargo as a fuel, special requirements, operating, and summary of minimum requirements. So we are also asked sometimes the advantage of using cargo as a fuel, which we saw. Then there are some appendixes. Then certificate of fitness for gas is there. So the purpose of the code is to safe carriage of gases and minimize any accidents, and it gives all the requirement how to be safe.